Good morning. Today we are talking about translating functions, so just what the graphs would look like when we translate them. And remember, a translation is a slide left, right, up, or down. So it's similar to the way that numbers are classified into sets of common characteristics. Functions can be classified into families of functions. The parent function is the simplest function with the defining characteristics of that family. So, for example, quadratic would be x squared. A linear function would just be y equals x. A cubic function would just be x cubed. And a square root function would just be the square root of x. So just the most basic, the original function. So it says identify the parent function from its function rule, then graph it on your calculator and describe the transformation. However, we have already talked about these transformations before. So our parent function is going to go in this row. So our parent function here, I see I have a quadratic, so it's going to be f of x equals x squared. And we have a minus 3 on the outside, so this was a translate down 3 units. Here, for number 2, I have g of x equals the square root of x plus 3. Square root of x is what's going on here, so the parent would be f of x equals the square root of x. And again, we have a plus 3 on the outside, so this would be up 3 because it is a positive 3 on the outside. In number 3, I have x minus 2 cubed. That cubed tells me that this parent function is going to be x cubed. And we have the minus 2 inside the parentheses, so remember when it's happening directly to x, often inside parentheses, but it's directly with that x, then it is either left or right. A minus is to the right and a plus is to the left. So this would be to the right too. I want to go back to the square root one real quick. If this had been g of x equals the square root of x plus 3 and the whole thing was in parentheses, now that plus 3 is happening directly to the x. So that would be to the left 3 because it's happening directly to the x. Almost the square root being over the entire thing almost acts like parentheses because the plus 3 is now directly to the x, not after square rooting the x. It's part of the square root. And remember, you can always graph these in your calculator and visually look at the original or the parent, and then also the transformed graph. All right, so it says as we work through this lesson, we're going to include more parent functions than those shown above. We have also graphed absolute value, exponential, and cube root functions. So here, it says identify the parent function f of x, describe a transformation of the parent function, and write an equation for g of x. So we're going to look at this graph here, look back at our original parent functions, and see which one it looks closest to. So it looks like the one that's all the way on the right, the square root function. So then the parent function would be f of x equals the square root of x. So again, remember that's f. To translate, it looks like I took these points and I went down 2 units. So that's going to be a minus 2 on the outside of the equation. So g of x will equal the square root of x minus 2. And a super easy way to check that your work is right is you can just type that in your calculator and then type square root x in y equals in your calculator, type square root x minus 2, making sure you arrow outside so it's on the outside, and then just double check that your graphs look like the ones they gave you. So these are the graphs that we've been working with, parabolas. We know them as f of x equals x squared as the parent function. So that is, f is the blue one. So then to get from the blue f of x to the red g of x, I'm going to look at my vertex here. It looks like I went down 1 and to the right 2. So now my equation, if I am going down 1, that's going to be a minus 1 on the outside of the function. And then to the right, that's going to happen in parentheses directly to the x squared. So instead of x squared, it'll be x minus 2. Because remember, when it's inside parentheses with the x, it's like the opposite. And then we're going down 1, so minus 1. All right, pause if you need to or go back and fill anything in. Otherwise, we're going to the next page. All right, number 6. The student was asked to graph the exponential function y equals 2 to the x minus 3 plus 3. Identify and graph the parent function on the graph below. Then describe the error made by the student attempting to graph. So let's start with the parent function. They did graph it for us. That is the graph in black, and let's just fill out the table here. So at negative 1, it was 1/2, or 0.5. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the second, 2 squared is 4. And 2 to the third, 2 cubed is 8. Again, those are just the y values from the graph. So, notice that our points here, our whole graph kind of shifted up and to the left. However, that's not correct. We have to find the error. So it says to go from y equals 2 to the x to y equals 2 to the x minus 3 plus 3, you would need to translate. So remember, this one here, the x minus 3, is happening directly to the x. So that means it's your right or left movement. So this would actually be to the right 3. And then the plus 3 on the outside, that is up 3. So that's what you're supposed to do. However, this person moved to the left. Oh, try and fit this. To the left 3 instead of right 3. So you got to be careful with the x values. If the number is directly with the x, it's happening to the x, then it's either right or left. Plus is to the right, minus is to the left. And again, you can always do these in your graphing calculator. So it says match the equation below with the correct graph, explain your reasoning, and draw the parent function on the set of axes. So we have the first one is a cube root graph. I know we've used a already today. This is a square root graph, so I know it's not going to be a. So a is going to go with number 8. In this square root graph, normally the square root is here because the square root of 0 is 0. And then go up from there. So it says the square root graph moved to the left 1. And again, that's because the plus 1 is happening directly to the x underneath that square root. So we've got some cube root graphs here. The original kind of looks like this. that's not the best graph here. It's kind of the cubed graph, but sideways. So here we have a +1 in the parentheses, or in the square root, so this would be like moving left 1, so you got to think which of these square root graphs move to the left, or cube root graphs move to the left, and that is this one here. So that is choice C. And then number 9, this cube root graph, the -1 means we went to the right 1 unit. All right, last question here. Graph the functions in the same coordinate plane. Do not use a graphing calculator. I know it says that. If you want to use a graphing calculator, that is perfectly fine. You get it on the Regent, so you might as well use it and get used to using it. So you can always use a graphing calculator. So in blue, I have the function f of x, which is x squared, my parent function, and g of x, I have x minus 3 quantity squared. The minus 3 is in the parentheses happening to the x, so it's to the right 3. And I also went up 2. So how you would do this is you would just take each of these points and move them to the right 3 and up 2. And same with this one, to the right 3, up 2. Same with this one, to the right 3, up 2. So you would just take each of the points and move them however the function says to. All right, now on to the homework. So, I know it says again, do not use a graphing calculator. You can use your graphing calculator. You do not have to do this without, you get it on the Regents. You might as well get comfortable using it for these types of problems. So, this is just graph 3 functions on the coordinate plane. So you're going to put them in your calculator and then make sure you label them. Which one, so like say this was f of x, you're going to write an f of x next to it. But obviously you're going to graph it with precise points. So just make sure you label them. Down below it says write a function that translates the graph of the parent function f of x where down 7 and right 2. So what would a down 7 look like to an x squared and right 2 look like to an x squared? And then this one is describe. So you're writing a sentence about how this +6 moves the graph and how the +10 moves the graph. Number 4, they give you the original, so this original one is f of x. It doesn't matter that you don't know the equation. Here, this is like it's on the outside. So how would that move the graph? And then here, it's on the inside of the parentheses happening to x. So you have to decide how those would affect it. Would it move it up 1, down 1, left 1, right 1, and then graph it? Would the x minus 3 be left 1, right, or left 3, right 3, up 3, down 3, and then graph it? You've got some main points here you're working with. So just these nice points, you can look at them and move them either left, right, up, or down. So you should end up graphing 2 more. And again, make sure you label both of them on your graph. On the back, I'll get you started on this one. So number 5, it says write an equation for the parent function f of x. They tell you it's a parent function, so this is a parabola, so I know my equation is f of x equals x squared. And then describe the transformation. Did we do this one already? Hold on. We did this exact graph right here, so you can actually skip this one because it's in your notes. But it's not quick to fill out if you do want to fill it out. We went down 1 and to the right 2, so this would be g of x equals, to the right 2 would be x minus 2 squared, and then down 1 would be a minus 1 on the outside. Oh, we're going to flip-flop these. It was down 1 and right 2 units. And then the last one is just describe the error, so they tell you how they thought it should move, and there's an error that you have to find. All right, you have the rest of the class to work on your homework.